So I start introducing Andreas Michalsky. Andreas Michalsky is a food technology engineer and flexible packaging specialist. His core competencies are applications for demanding packaging products and processes, transfer for rigid packaging to flexible packaging, and development of sustainable packaging with a total vision of sustainability. So I leave the floor to Andreas Michalsky for this presentation on the single-use plastic ban and possible solutions with bioplastics. So you can start.
Thank you. Thank you for this applause. You see, I'm the bad guy. I'm the one producing the packaging, producing the waste. Thank you for this possibility to talk amongst totally good people and good companies working on bioplastic and all this stuff. But if I take away my glasses, you will see a food technologist. And when I was studying and working, I was appreciating each good packaging, helping to preserve and market food and make it stable, make it safe and healthy. And this is the first part of my presentation. You see here a list of all demands that are put on packaging. And I will not go through it because it's quite challenging for each packaging. What I want to mention is that packaging is a part of a product sold. No packaging is sold for its own purpose, only together with the product. And also the packaging process is a significant part of food production. I assume approximately 30% in average. You can go through this later if you want. You see here a packaging material. You see the outside, the yellow side, and the gray side is the inside of the product. And I want to talk a little bit about the barrier functions because those were a main aspect of also work done in ECOFUNCO. You see the product, you see potential microorganisms on the outside, and you see different demands of permeation through this packaging material to be inhibited. We talk about barrier properties. And then, of course, this packaging also has to resist to some process parameters like sealing. Also, the influence of the product from the inside onto the packaging to avoid spoiling of the product, to avoid damage of things you have in your shopping bag, your laptop or your handy, your mobile, by the product has to be assured by packaging. Okay, and this was one too much, sorry. Packaging is a pillar of modern living. So food safety has reached a level we never had before. A good quality of products that everybody wants to have, a good taste, a good hygiene. We also have less diseases than we had many decades ago. We have an unbelievable availability of food, and as a provision in supermarkets without packaging would not be possible. It's a free choice of product you want to take. You see it here on the shelf. It would not be possible without packaging. Prepared meals offering a huge convenience, and they are a base for easy and quick cooking and more time for leisure. Also marketing, which is presented outside on the product, has a huge influence on sales and success of companies. And last but not least, also the globalization would not be possible without packaging with all its positive and negative impacts. So convenience, complete penetration of daily life, and packaging is a base for comfortable life and easy living. But you see this picture, everybody has in mind. This is a huge emotionalization since approximately 2015, and we all know that we have to react and change this. And politicians focused on the producers of packaging and make them change the packaging with a complete change from priority from cost, low cost, functionality, good barrier, to end-of-life sustainability. And these topics are dominating all discussions and all activities at the moment. And this discussion is dominated by the dogma that there is no compromise, and in a similar way is the legislation, especially in Europe, where the focus is on circular economy. This circular economy is mainly working with plastic packaging. And parallel to this priority, we have many laws currently that are pushed through legislation without listening to specialists like me, and I want to do the best for the products to be packed. The single-use plastic ban is one example I want to talk about now, and it was initiated by these pictures of marine littering, and people looked at some items that were found mostly in this littering, and of course packaging on the go is one of these items, and the single-use plastic ban tries to act on it. Also, this is only a small part of packaging, but it's the one with a big risk for littering. Also, in the single-use plastic ban, it's very strange that bioplastics are banned. They are treated same as fossil plastic. So even for them, they belong to the non-fiber content normally, and they have to be kept to a minimum. And this gives a focus from massive films of bioplastic to thin coatings of bioplastics that can be used for functionalization of fiber-based materials like cups and like paper and board. So this is a little contradiction. The European Union pushes circular economy of plastics and pushes development to paper packaging, fiber packaging, and in my opinion, politicians here act as consumers. They do not listen to specialists. They try to do miracles with a fiber-based packaging, which in its pure form has clear disadvantages versus plastic packaging. And these disadvantages have to be compensated by clever functional coatings. And all is driven by this opinion: plastic is bad and paper and bioplastic is good. But we have some limitations what bioplastics can provide or cannot provide. So they can provide a nice repellency against fat and oil, maybe even sometimes against humidity, but they cannot really provide a good barrier against humidity, for example. They can provide in a sufficient thickness also a barrier against fat and oil, and they can also react as a barrier for mineral oil, PLA, for example, or PBS. But the limited resistance against water and humidity is a huge hindrance in applying bioplastics as functional layers, because they are normally very sensitive to humidity. And even if they provide a good gas barrier under dry conditions, this is lost in most cases under humid conditions. And with many products, humidity and oil and gas demands go in one hand. So we have to find solutions how to handle this. And finally, we also heard today about antimicrobial properties. Here you see a survey of all products that have to be packed. You have on the left side, you have all the on-the-go packaging, which has a high risk for littering. And then you have, from the left side to the right side, you have products that are normally filled without big demands for the packaging. You have a medium column with medium demands, and you have the right column with very sensitive products, high demands for barrier. And then you have from the top down, you have dry products to be filled, maybe humid products and wet products. And also green areas. In these theoretically application of bioplastic for functionalization is possible. or on also the application of paper as packaging if it's properly functionalized. But if you come to the right side, it becomes very hard for bioplastic to fulfill these demands. Here, for example, Huhtamaki works with other functionalizations. You can also see that normally, if you look at the functional layer thickness, that for some products a very thin layer below 5 micrometer or maybe even just 1 or 2 micrometer can be enough. But if you come to more critical product, for example, if you want to achieve with a PBS or a PBAT a real humidity barrier, you have to work with more than 10 micrometer. I want to mention that bio-based materials currently have a very limited availability, and we have to also consider the competition with food. That's why ECOFUNCO is important. It looks to food waste, and it looks to materials which are normally not used for food. We also have to consider that bioplastics have today a limited recyclability, and they have a faster degradation than standard polymers, which so they cannot assure a very long shelf life of products packed. Another problem is the differentiation of bioplastic with non-bioplastic in the sorting systems, and the mixing up of both kinds leading to huge problems in recycling and also in bio-waste. Mono-packaging of bioplastic is consuming, in my opinion, too much of limited resources. If we produce a 500 micrometer biofilm, we consume a lot of bioplastic. And we normally, in Huhtamaki, we try to apply very thin layers to give the functionality, and we try to use, for example, a fiber substrate as base. If you look at mono bioplastic, it has today a total market share in packaging of clearly less than 1%. If you look at packaging containing paper in Europe, it has a market share of 35%, but 30% of this is complexes of paper with plastic film or even with aluminium. And a big part of these 35% has to be changed to meet demands of circular economy. And this is a huge task for us at the moment. Either keeps the paper and provides the functionality by other materials, or eliminates the paper and go for monopolyethylene or monopolypropylene structures. The potential for recyclable paper packaging is approximately 25%. And the potential for packaging with low and medium functionality is approximately 15% of all packaging currently on the market. There is some view also on the kind of disposal, and we have to consider where a packaging is put in. For example, all the on-the-go packaging is put in public waste, and public waste normally is not recycled. And this is another topic. I want to skip this now due to time reasons. Here you see a structure on the left side of a paper with very thick functional layers. And our target is to go to very thin functional layers and maybe even to apply them only in a pattern. And our target is not to use bioplastic. Bioplastic can make a paper packaging more sexy for consumers, but the huge priority is to have the paper packaging recyclable in the paper streams. This is the main target, and sometimes 1 micrometer of a polyurethane might be better than 5 micrometer of a PBS or PLA. Here you can see again such a paper. I showed a duplex. On the outside a paper, on the inside a cardboard, and we have to place, for example, barrier against humidity on the outside to avoid penetration of humidity to the inside, but we might also have to put a humidity barrier on the inside to avoid soaking of humidity from the product into the packaging. And we have sensitive barrier, oxygen barriers that we propose to put in the middle of a packaging, because then they are protected. They can be protected by outer layer humidity barriers. And on the right hand you see some materials that can be used, biomaterials, to fulfill these demands. and I have put the real biomaterials in green, and some other materials that are not bio-based but biodegradable, like PBAT or PVH, I have put in black or dark blue. This was the topic of ECOFUNCO, trying these layers to make a packaging and try to work with very thin layers. This is my mobile telling me that I have to finish. So I will hurry. You see here some other examples of Huhtamaki for packaging, paper-based with biofunctionality. And now I have to go to stop my mobile. Okay, thank you.
So, thank you very much for your presentation, Andreas. Okay? Yes. And are there any questions for Andreas? Any questions? Yes, just one. Okay.
Only a little question about your opinion on the recyclability of bio-based plastics and not bio-based plastics streams contaminated with paper or other cellulosic material. Do you mean it's possible to upcycle this type of material in a new material, a new plastic or composite material for a new application in the market?
Thank you for your question. This is a very important topic to look at the real recyclability. And for fossil plastic, we are working currently together in a big industry consortium called CFlex, with the whole value chain to improve the processes of collection, sorting and recycling, and we are on a good track. But currently, at the moment, for example, German recyclers are lacking plastic from the sorting. They would need more to deliver to the industry. So in my eyes, a key part where politicians do not look enough at is the collection from the households and also taking public waste into sorting. This is a chapter they do not like to touch because it's easier to tell industry what to do than to tell the people who are electing politicians to tell them what to do. This is for fossil plastic. For bioplastic, we have made some tests showing that each bioplastic goes into degradation with each recycling process. So my recommendation or my feeling is that this is more difficult than with fossil plastics, and especially the bioplastic needs to be sorted separately. And there is no stream today. In Italy, it goes to bio-waste. In Germany, there is no recycling stream. It goes to incineration. So we need to achieve critical mass to be relevant for the collection and sorting. And paper-coated, for me, the benchmark is not this 95% fiber content that is demanded currently. For me, the benchmark should be a real test for each material group, paper with functionalization layers. Is it okay for the paper recycling and the new sheet forming or not? And this can be even 80% fiber content. And it can be 95 if you have a very critical, sticky layer which cannot be separated from the fiber. Is this answering the question?
No. This was the principal, the main question I thought to ask you.
Okay.
So, okay, thank you very much again, Andreas Michalsky.